Hello, in this video we are going to look at a direct current circuit. We start off with a parallel circuit and then continue with a series circuit and finally a combination of series and parallel. In order to study the behavior of voltage and current across series, parallel and parallel combination, we are going to use three light bulbs, a brass rod. A long brass rod is connected to the positive and negative terminal of the power supply, a multimeter to measure voltage and current. The bulb has the same resistance. The brightness of the bulb will simulate the value of current across the circuit. The voltage from the power supply is set to 6 volt and the crocodile clip is used to connect the brass rod to the positive and negative terminals of the power supply. We are now going to measure the voltage across the brass rod. What we are going to do here is to measure the voltage across the brass rod. So as you can see here, the voltage is around 6.6 volt, more or less, because we don't have a fixed connections. That's why the reading fluctuate a little bit. So if you move the two legs of the digital multimeter further down, we are going to get approximately the same value. And as you can see, we get around 6.6. It's not very stable, but actually if you can hold it down, see, we get 6.6. So if we move it further down the rod towards the end of the rod, away from the terminal, to no surprise that we still get the same reading, 6.6 volt. So the voltage across the two terminals is always the same. We then measure the voltage across the terminal of the power supply and we get a value around 6.6, 6.7 volt. Any electronic component that is connected across the brass will have the same voltage. This connection is known as parallel connection. We are going to use light bulb to see the effects of parallel connections. We have three light bulbs arranged in parallel. First one, the second, and the third. We are going to connect the first bulb across the brass rod. The current flowing through the filament heats up the filament until it glows. That's why we are seeing visible light. And then we connect the second bulb. And we found that the brightness of the bulb are the same. And when we connect the third bulb, all three, the first, the second, and the third bulb, have the same brightness. And they are very bright because the potential difference across each of the bulb is 6 volt. So the current is pretty high. That is why they are glowing bright. We measure the current across the first bulb, we get 0.4 amps, and then from the second bulb we get 0.39, and then from the third bulb we get 0.41 amps. So when we measure the total current in circuit, we get 1.2 amp, which is the sum of the current passing through each one of the bulb, the first, second, and third. In parallel circuit, the voltage across bulb 1, bulb 2, and bulb 3 are the same. The total current in the circuit is going to be the sum of the current passing through bulb 1, bulb 2, and bulb 3. The current measured passing through bulb 1 is measured to be 0.4 amps, and through bulb 2, 0.39 amps, and bulb 3, 0.41 amps. So the total current in the circuit is the sum of all the current passing through all the bulbs, 1.2 amps. In series connection, we have the bulb arranged side by side. So this is the first bulb. Sit next to it is the second bulb, and then followed by the third bulb. This connection is known as series connection. So when we complete the circuit, we can see that all three has the same brightness, but the brightness is much lower than when they are connected in parallel. This is due to the lower current flowing through the bulb due to the increase of the resistance in the circuit. In series circuit, current passing through each element in the circuit is said to be equal to the total current in the circuit. So we measure the current in the circuit. The multimeter gives us 0.23 amps. So when we measure the current between the second bulb and the third, we also get the same value, 0.23 amps. And then when we measure the current between the first and the second, we also get the same value, 0.23 amps. So in series circuit, the total current in the circuit is equals to the current passing through each element in the series circuit. In series connection, the sum of voltage across bulb 1, bulb 2 and bulb 3 is equal to the voltage supply. The current in the circuit is going to be equal to the current passing through bulb 1, bulb 2 and bulb 3. The current in the circuit is measured to be 0.23 and the current between R1 and R2 also 0.23 amps. R2 and R3 we still get the same value, 0.23 amps, and the current in the circuit again is measured to be 0.23 amps. So the current passing through all the series elements are the same. To demonstrate that the brightness of the bulb is dimmer when they are connected in series because they have lower current, we connected two bulbs in series and then one bulb in parallel with the two bulbs. We can see that the two bulbs in series is dimmer compared to the one bulb connected in parallel to the power supply. The voltage across the single bulb is 6 volts. Thus, it's going to have bigger current. That's why you are seeing it as brighter than the series. To make things a little bit interesting, we modified the circuit. We connected two bulbs in parallel and they are in series with the third bulb. And when we switch on the power supply, we'll see that they will have different brightness. The one in parallel will be dimmer and the single bulb will be brighter. If we measure the current in the circuit has a value of 0.37 amp. And if we measure the current between the parallel and the third bulb, the current also read the same, 0.37 amps, because the two circuits are in series. So now we are going to measure the current of the parallel circuit. The bottom circuit has a current of 0.19 amps and the top circuit has a current of 0.18 amps. In this combination of series and parallel, when we measure the current in the circuit, we get 0.37 amps. And if we measure the current again between the parallel and the series, we get the same value of 0.37. When we measure the current in the bottom circuit, we get 0.19 and the top circuit 0.18, which is, if we add these two values, we get 0.37. And we measure again the current in the circuit, we get 0.37 amps. The current flow in such a way that when it meets the junction, it split up into two parts. And then when it meets again at the other junction, it's combined again and give us the total current in the circuit, 0.37 amps. That is it for now, and I hope you enjoyed the video and learned something new. Hopefully it's triggered your curiosity to learn more about direct current circuit. Thank you.